Good morning, students. Myself, Vijay Shankar from EC Department, Cheptal Engineering College. Today, we are going to discuss about the properties of Fourier series. This is a revision class, my dear students. It is in the second unit, the first revision. In yesterday's class, completed the syllabus of the last unit. And now we can start the revision in second unit, that is the properties of Fourier series. X of t as a Fourier series relation x of k. X of k is analysis equation and x of t is a synthesis equation. Using these two relations, mostly for the Fourier series, we are using this exponential Fourier series only for analyzing. All the properties also I have to prove that by using the analysis and the synthesis equation. The first property in the Fourier series, we already discussed this one. Again, you can go for the first property, the linearity property. So the x of t and the x of k having the Fourier series relations, as x of t is a signal, x of k is a coefficient of the Fourier series. And the second one, you can take y of t, the y of t having the Fourier series relation with y of t and the y of k, then the z of t is equal to a of x of t plus b into y of t. The Fourier series is a z of k is equal to a into x of k plus b into y of k. So I have to prove that by taking off z of t is equal to the combination of the two signals with the coefficients or the constants of a and the b. Applying the Fourier series for the z of t to get it is a z of k, and that is equal to of x of k and y of k with the multiplication factors of the constants a and b. The first I am taking as a x of k is equal to, what is the x of k? Is an analysis equation. X of k is equal to one by t, the integral, the t values, x of t as a signal, here negative exponential minus j k omega naught t dt. The Fourier series coefficient x of k is equal to 1 by t integral t x of t e power minus j k omega naught t dt. Using this relation, I have to prove the linearity property by taking off z of t as an input function, and to get the, after applying the Fourier series for the z of t, z of k. Follow my dear students. Now I will take the whiteboard and I will explain there. Showing that the linearity property, the first property, linearity, what they are saying, take the z of t, I have to prove z of t is equal to a into x of t plus b into y of t. Fourier series of z of t as z of k is equal to a into x of k plus b into y of k. Right. Take the proof. we know the x of k is equal to the analysis equation of the exponential Fourier series 1 by t, the integral t x of t e power minus j k omega naught t dt. According to the analysis equation, the exponential Fourier series. Take this as x of k is z of k is equal to 1 by t integral t. So what is the x of t now? If it is x of k, here the x of t. Now it is a z of k, here the z of t. What is the z of t given? A into x of t. So directly I am writing a into x of t plus b into y of t. The given x of t is z of t is equal to and e power minus j k omega naught t dt. Alright, students. Is a very important the properties of Fourier series, Fourier transformation, Laplace transformation, the Z transformations. The coming units we have. In the second unit is the Fourier transformation, and the last 2 units of the Laplace and the Z transformations. Okay, these are the very important properties. By using these properties only, you have to solve the problems, or you have to analyze the Fourier series, Fourier transformation for the periodic and the non-periodic signals. Understood, my dear students? So listen carefully. Z of k is equal to 1 by t, the given. I can write this integral as 2 parts as 1 by t, the integral t, a into x of t. For the first function also there is a multiplication factor of e power minus j k omega naught t dt plus the another integral, the integral 1 by t b into x of, not the x of t, it is a y of t, sorry, y of t. Use the small letters only for the signals x of t, y of t, and for the coefficients z of k, x of k, you can use the capital letters, my students. Y of t e power minus j k omega naught t dt. Alright. So here the a is a constant and the b is also constant. You can write it as a into 1 by t as a multiplication factor, integral t x of t e power minus j k omega naught t dt plus and b into, here I am taking the b as a common, b whole multiplied with the 1 by t integral t y of t e power minus j k omega naught t dt. See here in the parenthesis, whatever the a is multiplied within the parenthesis 1 by t, the integral t x of t e power minus j k omega naught t dt is similar to that of x of k equation only. You see the x of k analysis equation. So you can write it as a x of k plus, see here also the b is multiplied or within the parenthesis the one of the equation we have, that is 1 by t integral t y of t e power minus j k omega naught t dt. See, instead of x of t here it is a y of t. So when it is a x of t as a signal, the coefficient is x of k. When the signal is y of t here, the coefficient is a y of k. So a into x of k plus b into y of k. So that only they have to show that z of k is equal to a into x of k plus b into y of k. Following what is said, this is the first property in the Fourier series, the linearity property. Coming to the second property here, the significance of this linearity property. This property is used to analyze signals which are represented as linear combination of other signals. The significance of linear property is used to analyze the signals which are represented as linear combination of the other signals. Okay. So here also the same thing, a into 1 by t, the integral 1 by t. X of t e power minus jk omega naught t dt plus b into 1 by t, the integral t y of t e power minus jk omega naught t dt. So a is multiplied with x of k and b is multiplied with the y of k. Following. Coming to the time shift or the translation, second property, time shift or translation. I will show that in the whiteboard. The second property, time shift property. What is the statement here? The statement of time shift property. If x of t, Fourier series x of k, if x of t is the Fourier series x of k, then prove that x of t minus t naught. So the given signal x of t is shifted with the t naught samples. The Fourier series of that is e power minus jk omega naught t naught into x of k. Following my dear students. So in this, you take it as a z of t is equal to, and this one is a z of k is equal. You have to prove that z of k is equal. Okay. The proof of the time shift property. Coming to the proof, we know the signal x of k is equal to, or z of t is equal to, let us take z of k is equal to 1 by t the integral t, 1 by t the integral t, z of t e power minus jk omega naught t dt. This is z of t given x of t minus t naught. Okay. Otherwise, some little bit we are having. So this is z of t function, and this is the z of k. Okay, my dear students. Is equal to 1 by t, the integral t. So what is the z of t given here? X of t minus t naught. So I am taking this as x of t minus t naught e power minus jk omega naught t dt. All right, students. So how you can prove this by directly? It is not as x of t e power minus jk omega naught t dt. Instead of t here, t minus t naught is there. So keep these two terms as a single term, assuming let T minus T naught is equal to M. Let us assume T minus T naught is equal to M. Here the T naught is a constant. So apply the derivative on both sides. Apply derivative on both sides. So what is the derivative of T? dt minus, what is the derivative of T naught? 0 is equal to, what is the derivative of M? dm. Because T and the M both are variables. Here in this, the T is a variable. Now I am changing the T to the M variable. Okay. And the limitations is the same. There is no any change of the limitations because in the minus infinite to infinite, whatever the T is there, here the M is also the same. So I'm taking the same thing, 1 by T, the integral T, the limitations. So x of, I'm taking the T minus T naught is a M, e power minus jk omega naught. What is the T here? The T minus T naught is equal to M. T minus T naught is equal to M. From this, the T is equal to M plus T naught. M plus T naught. So replace here the T by M plus T naught into dt. Following my students. So now in the power there is a two terms are there. Split the two integrations. 1 by T, the integral T, x of M, and e power minus jk omega naught M. Sorry, it is not the dt. It is dm. Because we are changing it to the M values. So taking that the dt as a dm. Dm and another here e power minus jk omega naught into T naught, my dear students. Okay, you see this one, 1 by T, the integral T, x of M, e power minus jk omega naught M dm. This is the same equation here. Instead of T, here the three variables, the variable is a M and the x of M here. So you can write it as a x of k into e power minus jk omega naught T naught. So this is the same thing you have to prove, the x of k e power minus jk omega naught into T naught, minus students. It's a very important. So the shifting, how many samples it is shifted, the T naught samples. So for this function, the x of t minus T naught means for x of t, x of k is a Fourier series. For x of t, x of k is a Fourier series. For T naught sampling is shifted, the time is shifting. So see here the time t. If it is a frequency means k here. Converting of time to the frequency. Here the frequency is a k. So now here we are taking the time shift only. The time is shifted T naught samples. So it is multiplied with e power minus jk omega naught into T naught. That is a T naught samples. If suppose instead of T naught here there is another value is the 3 or 4 means e power minus jk omega naught 3, 4, whatever it is. Following my students. For the shifting of T naught samples, e power the exponential factor is multiplied with the T as T naught, e power minus jk omega naught T naught value. Let's go to the next one. So before going to that, you see here also the z of t is equal to x of t minus t naught. The Fourier series z of k is equal to e power minus jk omega naught t naught into x of k. See the proof, I'm taking the z of k is equal to the Fourier coefficients. 1 by d the integral x of t minus t naught e power minus jk omega naught t dt. Jk omega naught t dt. Let t minus t naught is equal to m. The limits of integration will shift by t naught, but again the integration is over one period. Hence, limits can be kept same. So I am not changing the limits of t, even if it is a t changes as m. Okay. So see the t minus t naught is replaced with m here, and the t is replaced with m plus t naught. So rewrite the expression 1 by t the integral t x of m. The first exponential e power minus j k omega naught m will multiplied with second exponential e power minus j k omega naught t naught. So within the parentheses, whatever we have here, that is equivalent of the quantity inside the square brackets is x of k. Inside the square brackets is x of k. Hence, z of k is equal to e power minus jk omega naught t naught into x of k. Understand, my dear students? Okay. The next one. Frequency shift property. Third one. Frequency shift property. The third property it is. Second property we already seen. Second is a time shift property, and the first one is a linearity property. Now it is the third one is a frequency shift property. Frequency shift. So the x of k minus k naught. X of k minus k naught. Let us see the proof of frequency shift property. What they are asking that here, if x of the statement is if x of t, the Fourier series x of k, then z of t is equal to e power j k naught omega naught t x of t. So take the signal as e power j k naught omega naught t x of t. Apply the Fourier series, then the z of k is equal to x of k minus k naught. Z of k is equal to x minus x of k minus k naught. Let us see in the whiteboard here, or otherwise directly I will explain here itself. So z of k is equal to, so what is the analysis equation saying that 1 by t, the integral t, z of t, e power minus jk omega naught t dt. Understood, my dear students? Now I am taking the z of t. They are asking that take that z of t is equal to e power jk naught omega naught t x of t. So z of k is equal to 1 by t, the integral t, this is z of t here, e power j k naught omega naught t into here the x of t is also there, x of t whole multiplied with, because this is z of t only. Here another function is there, e power minus jk omega naught t dt. Jk omega naught t dt. Now, see here is the e power is there, and here also the e power. So both the bases are same. Then we can add cos 1 by t, the integral t, taking the x of t here, x of t, here the e power, both the e powers only, e power, here the j is there, here also j, so I am taking the j as a common, here omega naught is there and the t is also there, so I am taking the omega naught, here the minus k and here the plus k naught. So keep the minus here. I'm taking here the k minus k naught. K minus k naught. Now you can see minus e power minus j omega naught k, and e power minus into minus is a plus. For k naught, the exponential is a plus here. And into the t also. So what is the three terms is a common, j omega naught t. I take here the e power minus is there. So minus into plus here the minus, wherever the k is there. And wherever the k naught is present, there is a plus. Minus into minus is a plus, dt. Now you can observe this total equation is similar to x of k is equal to 1 by t, the analysis equation, my dear student. Analysis equation, integral t, x of t, e power minus j k omega naught t dt also. So now you can observe these two equations. So z of k it is here. Observe these two. Here the x of k, this is z of k. 1 by t, the 1 by t, the integral t, x of t here, e power minus j omega naught t, and the k here, dt and dt. What is the value here? The k. So whenever it is a k here, the value is the x of k. Instead of k, what is the value here? K minus k naught. K minus k naught. So total equation, instead of k here, it is x of k. Now the right hand side equation becomes of x of, what is the instead of k here? K minus k naught. K minus k naught. K minus k naught. The frequency, x of k is the frequency, x of t is the time. In the time shift, there is a multiplication factor of e power minus j k omega naught t naught for x of k. But in the frequency shift, frequency is shifted. How many samples it is shifted? K naught samples. So that k naught samples is multiplied here for the time signal. For the time signal, my dear students. Following. So in the frequency shift, exponential factor, that is a positive exponential, my dear students. This is a positive exponential. Positive exponential with the samples of k naught is multiplied to the time signal in the time shift property, negative exponential with T naught samples are there is multiplied to the frequency x of. Understood? Once again, I will explain clearly. You see what I am saying, the time shift. In the time shift property, that is x of t minus t naught. So there is a shifting in the time with the t naught samples. What is the Fourier series here? Fourier series is e power minus j k omega naught, and since it is a t naught samples is shifted, t naught into x of k, the coefficient. Alright. In the frequency shift, see here, frequency shift means shifting occurs in the frequency. The shifting is in the frequency. So x of k minus k naught, my dear students. So in this case, the time is shifted with the t naught samples. In this case, frequency is shifted with the k naught samples. So now, the x of t is multiplied with, so in this case, x of k is multiplied with a negative exponential. In this case, the x of t, the time signal, is multiplied with the positive exponential e power j. How many samples it is shifted? K is the frequency. So k naught samples, k naught. But here I am not taking the k naught here. T naught. K naught omega naught into t. Now you can understand. So in the time shift property, the frequency or the Fourier series coefficient is multiplied with this factor. And in the frequency shift, the time signal is multiplied with this factor. E power j k naught omega naught t. Here, e power minus j k omega naught t. Okay, my dear students, see here the z of t taken as e power j k naught omega naught t x of t. E power j k naught omega naught t x dash. So remember this one. The time is shifted with the t naught samples is multiplied to the, after applying the Fourier series, the Fourier coefficient x of k is multiplied the negative exponential with the t naught samples. But in the frequency shift, with the shifting of frequency k naught samples, the time signal is multiplied with positive exponential e power plus j k naught, because it is a shifting the k naught samples, k naught omega naught t x of. Okay, my dear students.